So we've all seen AI that can write poetry and code, right? But what if it could also, say, do your grocery shopping for you or book your entire vacation, from flights to hotels without you lifting a finger? Today, we're diving into that next big step, AI agents. And this isn't just about generating text anymore. We're talking about AI that actually takes action. We're moving from digital thought to real-world results. Okay, let's start with a really simple question. A large language model, an LLM, can write you this beautiful, incredibly detailed essay about the history of Neapolitan pizza. But can it actually pull out your phone, open a delivery app, and get that pizza to your door? Well, the answer is a big no. And that really highlights the fundamental limit of a standard LLM. It's a brilliant processor of information for sure, but it can't directly interact with the world around it. And that is exactly where the AI agent comes in. You see, the huge difference here is the objective. With an LLM, you give it a prompt and you get back information. Simple enough. But with an AI agent, you give it a goal, like order me a pizza, and it has to reason, plan, and then take actions to complete that task. The output isn't just text, it's a completed job. Okay, so how does an agent actually make that leap from understanding a goal to, getting it done? It's not magic, I promise. It's actually a really carefully designed architecture. So let's break down the three key components that make up the anatomy of pretty much every agent out there. All right, first up, you've got the foundational model. This is literally the brains of the operation. A powerful LLM, something like Gemini, that provides all the core intelligence. But here's the key, it has to be specialized. For a stock trading agent to actually be any good, its foundational model needs to be trained on financial data, not Shakespeare. Makes sense, right? Next, we have the reasoning loop. I want you to think of this as the agent's central nervous system. It's not just a one-shot deal, not a one-and-done calculation. No, it's this iterative, cyclical process where the agent is constantly evaluating its progress, thinking about what to do next, and then making a decision. It's always thinking. And finally, the tools. These are the agent's hands and senses, and they are absolutely critical. The model might be the brain, but without tools, it's just a brain in a jar, right? It can't do anything. Tools are the bridge to the real world, allowing the agent to check your calendar, search a database, or, order that pizza. So we know an agent has this reasoning loop, but how does it actually think? I mean, it's not just random guessing. The agent's thought process is guided by some really powerful frameworks that let it plan and execute pretty complex tasks. Well, two of the big ones you'll hear about are chain of thought, or CoT, and another called ReAct. Chain of thought is all about internal reasoning. It's basically like teaching the model to think out loud, to break a complicated problem down into smaller, logical steps. ReAct, on the other hand, is built for interacting with the outside world. It's for when the agent needs its hands to go out, do something, and see what happens next. So let's really walk through that ReAct cycle step by step. Imagine you ask for a good Italian restaurant. First, the agent thinks, okay, I need to find places nearby with good reviews. Then it acts, using a search tool to look that up. After that, it observes the results. It gets back a list of restaurants. Finally, it iterates. It analyzes that list and decides the next step, maybe checking a menu or maybe booking a table. And this loop just keeps going until your goal is met. And here's something cool. On top of these frameworks, developers can also tweak the agent's whole thinking style. By adjusting a setting called temperature, they can control how creative it is. A low temperature makes the agent behave very predictably, just sticking to the facts, which is perfect for data analysis. But a high temperature? That encourages more creative, sometimes even surprising outputs, which is awesome for something like brainstorming. Right, so the reasoning loop is all about deciding what to do. But the agent still needs a way to actually do it. And that, my friends, is where the toolbox comes in. So what kind of tools does an agent even have? So these tools basically fall into four main buckets. You've got extensions, which are just standard ways to connect to external APIs, like a travel booking site. Then there are functions, which are specialized, reusable bits of code for common tasks. Data stores give the agent access to databases, so it is up-to-date info. And finally, plugins, which are like ready-made integrations that add specific skills, like getting access to your calendar. Okay, to see how this all clicks together, let's look at a real-world example, a meeting planner agent. First, it might use a document AI tool to read addresses from an invite you've uploaded. Next, it uses the Google Maps API extension to get the exact coordinates for those addresses. And finally, a custom function analyzes all those coordinates to find the most convenient, central spot for everyone to meet. See, it's a perfect example of how an agent can string together multiple tools to solve a pretty complex problem. All right, so we've got the brain, the reasoning loop, and the toolbox. But how does this all come together in the real world today, in the agents that people are actually building? To understand that, we got to look at how they've evolved to get here. If you look back, we started with what are called deterministic agents. Think of those robotic phone menus that say, press 1 for sales. They follow a very strict script. Then came generative agents, which could actually understand natural language. The next big step was connecting them to live data with a technique called RAG, making them way more factual and up to date. And all of that brings us to where we are today, the hybrid agent. And this is where we land today with the hybrid agent, which really is the best of both worlds. It combines the structured, logical, predictable thinking of a deterministic system with the flexible, creative power of a generative model. And that combination creates agents that are both powerful and reliable enough for really complex real-world tasks, like managing entire supply chains or even performing automated scientific research. So, all of this leaves us with one final, really big thought. We now have AI that can truly bridge the gap between digital reasoning and physical, real-world action. It can observe, it can reason, and it can act on our behalf. So the big question isn't just what these agents can do, but what new, complex, and maybe previously unsolvable problems are we now equipped to tackle? The possibilities are really just beginning to unfold.